Today, we're going to talk about the Honors Algebra 2 Edgenuity Section 7.3, which is called Multiplying and Dividing Rational Expressions. The objective for this section is to perform multiplication and division of rational expressions. So, exactly what it says, right? Let's look at a problem, and all the problems are going to work in pretty much the same way. What we're going to do is we're going to pull everything apart, factor everything apart as much as we can possibly factor it apart, and then hope that we can cancel things on the top and bottom. Now, this is going to work as long as we have multiplication of some sort between the two things, and then we're going to have differences in how the multiplication looks. But as long as it's multiplication, we can handle it. If we start throwing addition or subtraction in between two fractions, then we start having a much more difficult time. Okay? So let's look at what we can pull apart. The only thing that you can really pull apart in any significant way here is this piece right here. So let's talk about, okay, so fractions, you do top times top, bottom times bottom when you're multiplying. So it'll be 3 times, and when I look at this, notice that I could pull a 4, that is, both of these numbers are multiples of 4, so I could factor 4 out of both of them, and both of those terms have at least one x in it, so I could factor a 4 and an x out of there. Now, you could also do that separately if you don't see them both together right away. So what happens is, if I factor a 4x out, it's kind of like dividing a 4x out of all of these things. So if I do 4x squared divided by 4x, 4 divided by 4 is 1, x squared divided by x is just x, so I have 1x, or just x. And then plus, that's that plus right there. And then if I divide 8 divided by 4, I get 2, and x divided by x gives me 1, so the x's are gone there. And notice, if I were to distribute back, I would get this again. Okay? So there's all that. On the bottom, let me just write things next to each other. 4x times x plus 2. And the idea is to get things that you can cancel. For instance, this stuff I could look at grouped together and say 4x divided by 4x is 1. And x plus 2 over x plus 2 is 1. Now, that only works because I've got the x plus 2 grouped together and I'm canceling the entire x plus 2 in both cases. What I can't do is just, like, okay, so let me put this in a different color so that you can see that I'm not supposed to. I couldn't do this and this all by itself. That is not something you want to do. You have to do this entire x plus 2 and this entire x plus 2. You can't cancel things between addition and subtraction. So since I've canceled all that, all I've got left on the top is a 3. And if I've canceled everything on the bottom, that becomes a 1, and 3 divided by 1 is just 3. I will pause for a moment to let you look at that and see if you have questions. Okay, there being no questions, I will move on. Now let's look at what happens if we have 3 problems together. Well, looking at all this, this is really the only thing that I can probably take apart in any useful capacity. So let me try and factor this. And the way I would do that is I want it to factor into 2 parts. I've got k here, and I should have k there. that gives me k times k in the distribution will be k squared. And then if this operation is a minus, then one of these operations is a plus and one of them is a minus automatically. It doesn't matter what this one is. If this is a minus, one's a plus, one's a minus. And then you have to ask yourself, are there two numbers that multiply to make this number and do that to make that number? So two numbers that multiply to make 12 and subtract to make 4 are 6 and 2, right? 6 times 2 is 12, and 6 minus 2 is 4. And then the bigger number goes with that. So the 6 with the plus, and that means the 2 with the minus. Okay? And then I've got times 10 there, and times a k, and all that goes on the top. And then I've got times 5, times k plus 6, times 2. So notice that there's a 10 up here, and if I did 5 times 2, I would get 10, or if I broke down 10, I would get 5 times 2. You can think of it either way. So what I'm going to do is say the 10 can cancel the 5 and the 2 together. The k plus 6 can cancel the k plus 6. So we're left with nothing on the bottom, which means a 1, which means it's going to be the top divided by 1, so I can ignore the bottom, right? Anything divided by 1 is that thing. So what I've got is k times k minus 2 for my answer. Let me put those equals a little closer. And then I can distribute that k and have k squared minus 2k if I wanted to. But I do want to point out, this is a perfectly acceptable answer. This is a perfectly acceptable answer. I'll pause for a moment to see if there are questions. Okay, there being no questions, I will move on. So now we want to find the product. That just means we're multiplying. And one thing that is important to know, when you're doing a fraction times something that is not a fraction, you take the thing that is not a fraction and you multiply it to the top only. Okay? So that's an important detail, and let me illustrate that. That means I've got 8 times 9n squared minus 4 over 6n minus 4. Now, you might be tempted to cancel 4s, but remember, you can't cancel between subtraction or addition. So I can't actually do that. Instead, I've got to find a way to pull things apart. Okay? So I've got that 8 there. And then look closely at this. This is what we call a difference of squares. And a difference of squares always factors the same way. It factors into two pieces. Difference because of the minus sign there. It factors into two pieces. You take the square root of the first one and the square root of the second one. So square root of 9 is 3, square root of n squared is n, and you put that at both fronts, right? Square root of the front goes to the square root of, or goes to the front of both factors. Both factor pieces, I guess. And then the square root of the end goes at the end. So square root of 4 is 2, And then, in between, you get a plus one time and a minus the other time. So that's how the difference of squares factors. Over, now notice here in 6n minus 4 that 6 and 4 both divide by 2. So I could actually factor a 2 to the front of that. And if I do that, I divide each part by 2. 6n divided by 2 is 3n, minus 4 divided by 2 is 2. So now I've got the 3n minus 2's that do indeed cancel. I've also got 8 divided by 2. Okay? Now you can think of that as 8 divided by 2, or you can think of 8 as 4 times 2. And I'm going to write this out so you can see it as clearly as you can. I'm not going to write the canceled parts. So there's 2's that will now cancel. And then I could redistribute the 4 and have 12n plus 8 over 1, which anything divided by 1 is itself, so I don't have to worry about that. And there's my answer. You could have also left it as 4 times 3n plus 2, although that isn't fully simplified. So if they demand that it be fully simplified, that wouldn't work as your final answer. So that one is not fully simplified. The other one is. Okay? I'll pause a moment to let you look at that, see if there are any questions. Okay, there being no questions, I'll move on. Let's try another one. This time we're going to throw division into it. But division is just a form of multiplication, okay? Division is multiplication by reciprocal. And what that means is that to turn this problem into a multiplication problem, I can use, there's a mnemonic for this. It's called keep, change, flip. Okay? So to turn this into a multiplication problem, you keep the first thing, change to multiplication, and flip the second thing. Just like that. Okay? So there we have that. Now we got to start factoring things out, pulling things apart, doing all that. So let's take a look here. Look at this. I could factor a 3 out of that, right? All that stuff can be divided by 3. When I do that, I get 2x minus 1. That is, 6x divided by 3 is 2x, and 3 divided by 3 is 1. Okay? 12. Instead of writing it as 12, I've got a 6 up here. So it's going to be more convenient to write that 6, or that 12, as 6 times 2. Okay? So we're going to do that, and let's just keep going top times top, bottom times bottom, so we can turn it all into one big fraction. So times 6 times x, I'm just pulling those apart to illustrate the canceling of the 6 more than anything else. And then at the bottom, 2x minus 1 all squared means 2x minus 1 times another 2x minus 1. And again, I'm doing that so that I can do cancel, 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 cancel. And what that allows me to have is, on the top I've got 3 times x, which is 3x, and on the bottom I've got 2 times the quantity 2x minus 1, so I can distribute that 2 and get 4x minus 2. So this becomes my final answer, because remember, just because I have an x here and here means nothing as far as cancellation. You can only cancel between multiplication. This minus holds this entire thing together, and it could only be canceled with something that looks exactly the same. In other words, another 4x minus 2. But I'm never going to be able to create another 4x minus 2 out of that, so I can't do any canceling. So this is my final answer. I'll pause a moment to see if there are questions. Okay, there being no questions, I will move on. I thought I was going to need more space for that one, so don't need that. This one I've got another thing for. So let's do keep change flip on this one also. And as we do that, let's think about factoring at the same time, okay? So the first thing I always do, when you've got like 2s and 3s at the front there, things get a little weird. But what I do is I say, okay, I need 2x squared, so that's 2x times x. So that's at least a starting point. I need to multiply at the ends to make 3. There's only one way to do that, 3 times 1. So it could either be 3 and 1, or it could be 3 and 1. The minus here means one's going to be plus, one's going to be minus, but I don't really know that combination yet either. What I do know is that I'm going to have to multiply there and multiply there and subtract them to get 5, or 5x. So if I were to put the 1 here and the 3 here, I'd have 2x minus 3x, that'd be negative 1x. That's not 5. So let's try the other way. And of course, these might not always work either. But 2x times 3 is 6x. 1 times x is 1x. 6x minus 1x is 5x. So that works. And then I just got to make sure that the negatives and positives work out right. I need negative 6x and positive 1x to account for that negative sign, that minus sign right there. So I need the 6x to turn out negative, so that'll account for that, because now I've got negative 3 times 2x. And I need the 1x to come out positive, and that'll account for that. So there's one. Well, let's try the next one. Now, when you look at these, the first thing you should do is say, okay, could I factor a 4 out of it or a 2 out of it? And if you can, do that first, because it's going to make everything a lot easier. But I can't do that. So I'm hoping this will factor into 2 pieces. The only thing that I really know is how to make 5. I can make 5 with 5 and 1, right? The other thing I know is that when there's a plus right there, they're both this. So I know that I've got a plus there and a plus there, which is really nice, because then it doesn't matter whether my 5 goes there and my 1 goes there, or whether they go in the other one. All I need now is combinations that multiply to make 4x squared that work in combination with these multiplications to add together to make 12x. So how am I going to do that? Well, 5 times 2 is 10. 2 times 1 is 2. So if I did 2x and 2x, then I would have 2x plus 10x is 12x. It takes a lot of experience in doing a lot of these to get real good at them. I'm able to look at them and sort of figure this out, mostly because I've done a ton of them. And that would be my advice to you. Do lots of these. Do lots of practice. Go on any internet search and type in factoring quadratics, and there'll be a lot of online practice for this if you need the practice. So we have kept the first one and factored it. Now we need to change to multiplication, and now we need to start flipping and factoring the second one. So this is what I'll work on factoring first, and that factor will go on top because I'm flipping things over. So again, I need things that multiply to make 6x squared. I need things that multiply to make 10. This one requires more thought because there are more factors to check. Okay? But the way I always do this is I say, well, what if I use the easiest combination? So I'm going to have to subtract. What if I use 6 and 1 and 10 and 1? Okay. Well, I could do, if I do 6 times 10, that takes it out of it all the way. But what if I do 6 times 1 and 10 times 1? That'll be 10 minus 6, which is only 4. So I don't want to use 6 and 1 and 10 and 1. What if I use 6 and 1 and 2 and 5? Well, let's see. 6 and 2 is 12, but 1 and 5 is 5, and 12 minus 5 doesn't make 11. So if I could do 10 and 1, that would be helpful. Well, 5 times 2 is 10, but then I'd have to use 3 times 2 is 6, so that doesn't help either. What about 3 times 5 and 2 to, 3 times 5 is 15, 2 times 2 is 4, 15 minus 4 is 11. So, I'm going to use 3x and 2x. And then the multiplication has to work to make 15 and 4. So that's how that's going to work. And then I need the 11 to turn out positive. So I need a positive 15 and a negative 4. So there's that factor. And then I need to factor this, and because I'm flipping, it'll go on the bottom. The one nice thing about that factor is 3x squared. There's only one way to make it, 3x and x. A plus here means both operations are that. So I know it's minus and minus, so now I just need the right combination of factors that multiply to make 6, and then I need to add everything so that it comes out to 11. So, I don't know, 6 and 1, 3 times 6 is 18, that'd be too big. 3 plus 6 is only 9, so I can't do that. So 2 and 3 are my other options. Ooh, 9 and 2 works. If I put a 3 there, that's 9x. If I put a 2 there, that's 2x. And so I would get 9x plus 2x is 11x, or actually negative 9x, and negative 2x is negative 11x. So I've got everything factored. Now that I've got everything factored, I'm going to look at it again and go, okay, what cancels? Well, that cancels. The 2x plus 5 on the bottom and this 2x plus 5 on the top cancel. This 2x plus 1 can cancel with this 2x plus 1. This x minus 3 can cancel with this x minus 3. And look at that, everything has canceled, which means I had the thing over itself, meaning my answer is 1. Isn't that incredible? I really thought I was going to need more space for that one, but it turns out that I didn't. So I will pause for a moment, let you look at this, see if there are questions. Okay, there being no questions, I'll move past the blank board and on to another one. Now, Edgenuity calls this a complex fraction. It's a pretty typical way of denoting this type of problem. However, I have to say that I never like the term complex fraction for this, because when you say the word complex in math, you should be talking about imaginary parts, imaginary numbers in what you're doing. That's what a complex number is. So I try and avoid, these are a more complicated fraction. I don't like the word complex, but Edgenuity does use it. But this is the same idea. You've got this thing divided by this thing. And the idea is to just do the same old keep, change, flip. Turn it into multiplication. Okay? So that'll be 36 p to the 4th over 6 times the reciprocal of this. And the reciprocal of that is simply 1 over that thing. And now I need to work on this. Okay? Pull apart as much as I can that makes sense. Well, 36 divided by 6 is something that I can do. So let me just do that. 36 divided by 6 is 6. And then this p to the 4th, and so this whole thing as 6p to the 4th, I could multiply to the top and multiply by 1. So that'll just be the top of this fraction. Now this, I could pull a p squared to the front of that, factor it to the front, and if I do p to the 3rd divided by p squared, that is, I take 2 p's out of the 3 p's, I'm left with 1 p left, plus if I take these 2 p's out, there are no p's left, and I'm just left with plus 3. And then you can take this and you can say, well, that is the same as p squared times another p squared, right? I'm just writing the 4 p's in a format that helps me a little bit more. Over p squared times p plus 3. And then this p squared cancels one of those p squareds. And you get 6p squared over p plus 3. And that is as far as I can take that. Because remember, the plus down here is keeping all that together. I'd have to cancel it all together. And since I can't do that, I can't cancel any parts of it. I'll pause to see if there are questions. Okay, there being no questions, I will move on. I think I've got another blank that I thought I was going to need, but I didn't. And now for a big one. Okay. One this big, we are going to do keep, change, flip. But one this big, I like to do a bunch of factoring and see if I can cancel stuff within each set of fractions. So let's see if I can cancel stuff there. Let's see if I can cancel stuff there when I factor. And then I'll rewrite it and see what I have, and then I might be able to factor more stuff, cancel more stuff as I do the keep, change, flip, as I turn it into multiplication by reciprocal. So the top y factored out, so I get y times y plus 1 over the bottom, which I can also factor out a y and get y minus 2 there. So already I have y's that can cancel there. Okay? So then on the bottom, I've got a 4 that can factor out and be left with y plus 1 over, this should factor into two parts. Let's take a look here. I need y and y. This plus means both operations are that. So minus and minus, and then I need two things that multiply to make that, and do that to make that. So two things that multiply to make 4, and add to make 4, which is 2 and 2. Nothing cancels there, but it's going to give me something as I do keep, change, flip. So it's going to be y plus 1 over y minus 2 times, and then flip here, y minus 2 times y minus 2, all of that over 4 times y plus 1. And then the y plus 1's cancel. This y minus 2 cancels one of those y minus 2's, and I'm left with a y minus 2 on the top and a 4 on the bottom, and that's all that's left. So that is my answer. I will pause again to see if there are questions. All right, there being no questions, I will end this recording because that was our